Alright, so we're going to talk a little bit more about right triangles, and this is something called trigonometry. Okay, trigonometry is the study of triangles, and people happen to notice, and since we just talked about proportions, it's always good to talk about trigonometry next, because proportions actually give rise to the idea of trigonometry. They noticed that no matter how you drew a triangle, whether it's big or small, if you took two sides and divided them, like either the, let's say this divided by this, B divided by A, let's say we took the height of a triangle divided by the length of the triangle, no matter how big the triangle got, okay, if you kept certain angles, these two ratios, this ratio of B to A would stay the same. No matter how big the triangle got, no matter how long it got, as long as these angles stayed the same, these ratios stayed the same. So it was a really unique situation. So what happens is, and I don't know if it's the ancient Egyptians or the Sumerians, I want to say someone in the Middle East. It might be the Egyptians, it might be ancient Turks. But anyways, they started to discover this relationship and stuff, and so they started to call them by certain names. They started to call a certain relationship between the adjacent side of an angle and the hypotenuse, the cosine. So this actually turned into cosine is equal to the adjacent side, and you're going to pick an angle and then you just divide by the hypotenuse. Okay, alright, so that was cosine. Sine was you take the opposite side from an angle and you divide it by the hypotenuse. Okay, so like for example, if we were focused on this B down here, we would be doing this divided by this. So they looked at that relationship. And then tangent was, okay, tangent was you take the opposite side and you divide it by the adjacent. So opposite, let's divide by adjacent, and adjacent means next to. Okay, alright, and that's when they came up with some things called trigonometric ratios. Now specifically they stuck around, if you remember or if you remember your special right triangles, they stuck around with special right triangles, and we'll discover more of that when we get to trigonometry. But for right now, we're just going to understand the ratios. And the best way to actually remember that is SOHCAHTOA. Okay? And SO is sine equals opposite divided by hypotenuse. Notice the O and the H. Cosine is adjacent and divided by hypotenuse. And tangent is opposite divided by adjacent, so it's a helpful reminder. Okay, so take some time at home. I actually have the answers underneath these boxes. Take some time at home to think about what the sign of this is called beta, okay, and this is called alpha. So use this as a reference point. Try to find the sine of the opposite divided by the hypotenuse, and then the cosine of the adjacent divided by hypotenuse, and the tangent of opposite divided by adjacent. And so this is, hold on, let me see, is this B? Yep, that's beta. So we're going to take a look at beta, and this is what it would actually look like. Okay, so what you do is you put sine next to the angle, or cosine, or tangent. You put it next to the angle, and then you write an equals, and then it's going to be a ratio. It's going to be a side divided by a side. Okay, and that's why we talk about trigonometry right after talking about proportions. Okay, so now try pausing the video and trying it out with A, or alpha. Alright, and now we're back, and sine of alpha is A divided by C, cosine of alpha is B divided by C, okay, and tangent of alpha is going to be A divided by B. Okay, now if you notice some relationships here, here's some cool stuff. Sine of alpha and cosine of beta are both the same. Cosine of alpha and sine of beta are the same, and these two are just reciprocals of each other. So that's some kind of cool stuff. Yay, look, I made a smiley face. Okay, so right now, hold on. 16 plus 36, yep. 16 plus 36, yep, that works. Okay, 16 plus 36, yep, that is. I had to double check that. Okay, this is a right triangle. I have the angles X and Y in here. Okay, and then we'll talk about finding x and y in a second. You can actually use all of the sides of a triangle to actually find the sides of x, or the angles of x and y. Okay, but we're just going to find some ratios. So we're going to find sine of x first. So once again, we're going to use SOHCAHTOA. Always write this down at the top of the paper whenever you're doing trig. It just helps. It makes a whole lot of sense. So sine is going to be opposite over hypotenuse, and it's going to be x. So opposite of x is going to be 4, and then hypotenuse is going to be 2 root 13. So when you write this out, okay, so when you write this out, it's going to be 4 divided by 2 root 13. Now I don't like it non-rationalized, so just multiply top and bottom by root 13, and this should be 4 root 13 divided by 26, which should reduce this to 2 thirteenths. There we go. That looks much nicer. Okay. Alright, so that works out pretty good. Now cosine of y, and I'm going to get rid of these real fast. Delete, delete. Okay, now we're going to focus on cosine of y. So cosine of y is going to be adjacent, okay, because if you remember, it's adjacent over hypotenuse. So it's adjacent, so that's 4 over 2 root 13. Well, that looks a lot very, very familiar, so I'm just going to rewrite the whole thing. So 2 root 13 divided by 13. Okay? Alright, now some of you guys are tempted, oh, I'm going to divide the two 13s and get square root of 1, and this just simplifies to 2. Do not do that. That's inside of a square root, okay? Alright, and plus if you were to write it in Desmos this way and have the 13 on the outside and you're dividing the whole top part, here, let me show you. This is the proper representation to put it in the Desmos to prove me right and you wrong. Put it in like this and it will not simplify it to that, okay? Alright. Now if you notice they're both the same, well, if you remember on the last slide, we talked about two different angles, sine and cosine are going to be the same. So that's actually kind of interesting. Okay, so that also means that sine of y is equal to cosine of x. Okay, now tangent of x, we're going to get rid of these bad boys. Okay, so tangent of x is going to be, so there's x, it's going to be opposite divided by adjacent. So it's going to be 4 6, which reduces to 2/3. Okay, and tangent of y is just going to be the reciprocal of that, so it's going to be 3/2. Okay, now if you're really itching to find out what sine of y is and cosine of x is, okay, we'll go ahead and sit here and calculate this. So sine of y, so once again, when doing this, I strongly recommend drawing the triangle and then, marking it up. I mean, just like what I did. Just take your time, figure out what angle you're dealing with, and then figure out the opposite, the adjacent, and the hypotenuse side. So sine of y, so we're using this, it's going to be opposite over hypotenuse. So it's going to be 6 divided by 2 root 13. Okay, now if you notice the 6 and the 2, they both share numbers, so I can reduce that to 3 over 1. So this turns into 3 root 13, okay, which turns into 3 root 13. I'm going to write over some other one, divided by 13. Okay, so let's move this over a little bit. Boom. Boom. There we go. Okay. Alright, and cosine of x is also going to be the same, because if you notice, when I start figuring out it, let's figure this out. Cosine of x is going to be adjacent over hypotenuse, so cosine of x is going to be this divided by this, same exact thing. Okay, so we actually found all 6 ratios here. So 3 root 13 divided by 13. Okay. Alright, now, if you were given a ratio but you don't know the actual triangle, you can actually draw a triangle from it. So like, for example, find sine of y if cosine of y is 3/5. Okay, so what you do, and this is actually a trig problem. I did give you a problem from pre-calculus / trig. Okay, so what you do in this situation is you actually draw the triangle and you construct it from your information. This is the cool thing about trig, is that you can almost reverse engineer a triangle from it. Okay, so doesn't matter what you set y as, you could set it right here. So if cosine is there, then this is 3 and this is 5. Okay, and I just follow SOHCAHTOA. Alright, so to find this side, I'm going to set up Pythagorean theorem. So I'm going to go 3 squared plus, I don't know what that is, let's call that b, okay, and that's going to be b squared, alright, equals 5 squared, okay, and that turns into 9 plus b squared equals 25, okay. I minus 9 from both sides, and b squared equals 16. And if I square root both of those, square root, I should get b is equal to 4. Okay. Now that I know that this is 4, and it once again doesn't matter what letter you use for it. Okay. If you notice, that's Pythagorean triple. Okay. All right. Now what I'm going to do is I'm just going to find sine of y. Well, sine of y is just the opposite over the hypotenuse. Okay, and so sine of y, and do not say sin, please, for the love of all that is holy, do not say sin. That is sine, cosine, and tangent, okay? All right, and you can actually reverse produce a triangle that actually works with this, okay? All right, now just a huge warning right here, and I'll bring it down a little bit. Okay, 30, 45, and 60 degrees are special and useful for a reason, but other angles are harder to work with. Be careful to stick to the basics until later. You'll learn more toys and methods as you progress in your math career for trigonometry. So when you're dealing with angles, you're probably going to be dealing with some nice looking ones, okay? All right, so now what we're going to do is find x and y using the arc sine and arc cosine in the problem in the upper left-hand corner. Okay, and I just realized that I spelt that incorrectly, so let's put, for some reason I like to type, as soon as I type I type, it's almost like the texting thing. But anyways, alright, so I'm going to set it up. Okay, so what I've done is I've set up my trig ratio of the sides. Now if you notice, the only variable is the y. So I'm not going to divide by sine, I'm going to actually do the sine inverse of both sides, and we call that arc sine. So you're going to do arc sine of sine of y is equal to arc sine, and this is going to be a bunch of parentheses in here, so 3 root 13 divided by 13. Okay. Alright, so if you notice, that button will be in Desmos and you can actually do it, and it's going to be also what is called the sine inverse button on a TI calculator. Okay, it would be the sine inverse on your actual TI calculator. Okay, so what I've done is I've actually calculated it. Alright, and if you put everything into there correctly, these two should cancel out because they're inverses of each other. And then arc sine of this is actually, it's going to be a really cool thing. You have to make sure your calculator's in degrees, and in Desmos you need to definitely change it to degrees. So let's exit. Okay, and it's going to be 56.31 degrees. Okay, now I could find x by doing the tangent inverse of both sides and doing it like this. So x equals arc tan of 2/3. Okay, or I could just know the fact that inside of a right triangle, if this is right here, if this is 56.31 degrees, okay, all I need to do is subtract it from 90, so 90 degrees minus 56.31 degrees, okay, and I could actually find that as well, right? Or I could do arc tangent of 2/3. I only picked tangent because it's just different, you know. And voila, there you go. I've actually figured out what that angle was by doing the arc tangent of both sides. You could have done arc sine, arc cosine of either one of these, and you would still got the same answer. Okay, but if you set up the ratio correctly, it makes a whole lot of sense. All right, that's it for trig. I'll talk to you guys later. Bye.